Hi everyone. In this video I wanted to show you how to create a really nice animation for what is called an Isovist, as you can see here. So by the end of this tutorial, hopefully you will have an animation like the one you see on the screen. An Isovist is basically a type of spatial analysis where it records the kind of view that you see from a certain vantage point given a space and a set of obstacles within that space. So as you can see here, the Isovist method in topologicpy has been improved. It now includes a direction, an actual vector direction, so that you can set an eye and the target. And also it includes a field of view, what we call an FOV, that does not have to be 360. So you don't have to always get an Isovist that goes 360 all around, simply because if you would like to say, we're human beings with our eyes in the front and we see kind of part of the space, you can specify a field of view. And I think it lends itself to a more realistic analysis of the space. But you can also set, of course, 360 as a field of view to get the more traditional Isovist. If you have not been introduced to Isovist before, there is a Wikipedia page, which I will show you now, that you can take a look at. Just search for Isovist on Wikipedia, and you can read about visibility graphs and Isovists. All right, so let's set up the kind of the geometry and the methodology for what we are going to be doing. So let's first talk about what we are going to represent. So we will have, first of all, we are going to have a boundary, and this is represented here in this thick black line. And then we're going to have a set of obstacles, and those are those gray shapes that you see in the middle here. And then we are going to have two paths, like two wires. The first one is the path that the eye will take. So this is the travel path of eye, which will go like this. And we will find points on that wire. And then the other path, the pink one or the purple one, whatever that color is the target. So that's where you are going to be looking. So this is why you see the Isovist sometimes flip view, or flip direction, because the eye is here, it has crossed over, and then it's looking down in that direction, and then over here it will cross again and starts looking up again. There are some assumptions or some settings. Basically in topologicpy we consider that north is in the positive y, east in the positive x, south in the negative y, and west in the negative x. And what you see here in the kind of like the pie shape here, that is your field of view or FOV, and that's an angle in degrees. So how do we get this stuff into topologicpy? The good thing is that with the new two methods, export and import to DXF, you can now draw these things easily in, let's say, something like Rhino or AutoCAD, and bring them in as DXF files. So I will show you what I have drawn in Rhino. And as you can see here, I have drawn several of these pieces separately. So I have the boundary, I have the obstacles, and then I have the eye path and the target path. And then I select each one of those separately, and I export to export selected to PDF, and I save them here. So as you can see here, I have the boundary right there. I have the obstacles as a DXF file separate. I have the eye path and the target path. And we're going to bring those files into topologicpy. So let's get started. So as usual, we will use Jupyter Notebook, but you can use any Python IDE that you are comfortable with, like Google Colab or Visual Studio Code, and start a new script. I've already started it, and as I always say, the first two lines you do not need. Those I use those because I am on my development machine. But then what I would like you to do is to import, once you have pip installed topologicpy, of course, is to import the needed libraries. So the form is always from topologicpy.vertex, import vertex, from topologicpy.edge, import edge, and so on and so forth, as you can see them here. So make sure you shift enter and run this cell just to make sure that it's running well. And then we can get started. If this ran okay, then we are ready to go. So the first thing is to bring those DXF files. As I said, hopefully you have exported them from Rhino. You know where they are on the file system, and you can now import them. So the first one is the boundary. So I'm going to call that boundary. And I'm going to say it is topology by DXF. The DX and F are uppercase by DXF path, and the P is uppercase. And then I give it the path to the DXF file, which I know to be users Wasim J in this case, downloads, and then boundary.dxf. Great. So what I'm going to do now, I'm just going to print boundary just so that you can see what it is. And it is a list of edges. It's not a wire or anything like that. So you gotta inspect what you are getting from the DXF file, because different software will give you different results. The DXF import in topologicpy is still at a basic level. I'm using a library, EasyDXF, but I'm not importing, let's say, textures or dashes or anything like that. It's just basically the edges, the vertices, the polylines, and the 3D meshes as well. So you can bring in 3D geometry. So you can import and export 3D geometry. Great. So since these are edges, I'm going to make a wire out of them. So I'm going to say the boundary is equal to wire by edges boundary. So I'm going to convert it from a list into an actual wire, and I'm just going to reuse the same name. I'll do the same thing for the obstacles. So obstacles is equal to topology dot by DXF path, and then I can copy the same path here and just change the last word in it, and instead of boundary it's going to be called obstacles. Great. And we are going to in this case we are going to self-merge. Now why are we self-merging the obstacles? If I say topology.show obstacles, just let's go ahead and draw them onto the screen. You'll notice that they are 3 wires. So we need to merge them in order for it to kind of detect that they are 3 wires. So let's go ahead and do this. So what we are going to say is that obstacles is equal to topology dot self-merge, and I'm kind of combining it in one line. I'm saying it is a cluster by topologies obstacles. So what does this line mean? This means the first thing it's going to do is what's inside, which is cluster by topologies. So it's going to take the list of edges and it's going to make a cluster out of them. That doesn't do anything except kind of convert them into a single object made out of many edges, but it does not actually create a higher concept, a higher kind of topology. When you self-merge, it will do its best to detect what kind of circuits you have, what kind of loops you have. It will start welding vertices together, etc., in order to create the best type of representation that is possible. So in this case, topology.self-merge will create an actual cluster of wires. So we can go ahead now. We are not done with obstacles. So we self-merged it, and it created now a cluster of 3 wires. Now we would like to get the list of wires out of it. So we're going to say again that obstacles is equal to topology.wires of obstacles. So obstacles started out being a list of edges. We made a cluster out of it. We self-merged the cluster that gave us still a cluster, but it's now, instead of a cluster of edges, it gave us a cluster of 3 wires, and then we got the wires out of it. So if I now print obstacles, I should see a list of 3 wires. And here they are, 1, 2, 3, as you can see, topological wires. Great. So now let's go ahead and bring in the eye path and the target path. But before we do that, let's go ahead and build the actual face. So what I'm going to do is I'm going to reuse boundary again. Why waste space here? We'll reuse boundary, and I'm going to make a face by wires, because I have my wires. If you can let me go back to the image here. You can see that I have the external boundary of the face, and the obstacles are actually can be thought of as holes, right, as internal boundaries. So I can make a face out of the external boundary and the list of internal boundaries. So how do we do that? We say face by wires. The first input is the boundary actually, and the second input is the obstacles. And then we can print boundary just to check what we have. And now we have a face. If I say topology.show boundary, we have a face that has holes in it, and that's exactly what we need. Great. So now what's left are the 2 paths that we need to get in. So I underscore path is equal to topology by dxf path, and let's again copy the same path here and then call that iPath, and let's go ahead and make a wire out of it. In this case, iPath is going to be wire by edges because they are connected tail to head, iPath. And I will copy the same 2 lines here and use them for the target path. Just make sure you update the names correctly. Target path. Great. So now what we can do is let's show everything. So topology.show, and let's show the boundary, that's the face with the hole, the eye path, and the target path. And here they are, as you can see, ready to go. Great. So what's next? The next thing is I'm going to make a ground, just a ground rectangle, and then we're going to start with the loop. So ground is equal to face.rectangle, and I'm going to give it a width of 30 and a length of 30, just something to give like a bounding box of some sort. And then I'm going to translate it just a little bit so that it doesn't interfere. I'm going to translate means move. I'm going to move it a little bit. So topology.translate, and I'm going to move the ground. I'm going to move it 0 in the x, 0 in the y, but minus 0.5 in the z, just kind of to lower it a little bit. Okay. Great. So now we can start the new section. I'm going to give myself a variable called j, because I'm going to use that to name the PNG files in a kind of sequential manner. So I'm going to start with a variable called j, but I'm going to do start with a loop. So I'm going to say for I in range 0. For now, I'm just going to say from 0 to 2 in 2. in steps of 2. So I'm going to just input one image. And the reason I start with a small range is if I did something wrong, I don't want it to go for, let's say, 100 frames doing, wrong things. So right now I'm just making it do 1 or 2 images, and I'll check them, and if they work, I can then up that number to the desired number of frames that I need. So the idea here, just to set you up for what is coming next, is that we are going to move the eye and the target points along those paths. We're going to compute the Isovist at that location, and we're going to save the diagram to a PNG file. Once we have those series, and we're going to give it a unique name based on J. So we're going to increase or increment J by 1. Once we have all these PNG files, we can upload them to online kind of tools. Like I use something called EasyGIF or EasyGIF, whatever you want to call it, that will take a series of these PNG images and it will make them into an animation. All right, so we're gonna loop through I. I is basically a looping through 0 to 1. But because we cannot use a float number, what you really need to do is, let's say, loop from 0 to 100, and then use I and multiply it by 0.01 in order to get the number that you are looking for. And the last number 2 is the kind of step count, basically. So how many numbers do you want to skip? So, in this case, we're skipping by 2. Right, so right now I'm going to calculate what the U value is. U is a parameter on the wire that goes from 0 to 1, where 0 represents the starting point of the wire and 1 represents the end point of the wire. And 0.5 is somewhere in the middle of the wire in terms of distance, or travel distance, basically. So U is equal to I multiplied by 0.01, okay? For now, and we're going to calculate something called an I, which is where we are looking from, and that is going to be a vertex. So it's wire vertex by parameter. So you give this a wire and a parameter like U, and it will give you back a vertex that is on that wire at that location, at that parametric location. So we're going to say that we're going to give it I path as the wire, and we're going to give it U as the parameter. And we're going to have a target where that's going to look, and that's exactly the same thing, wire vertex by parameter, and in this case it's the target path and the same U. So now we have an I and a target. Great. Let me just bring this up a little bit here so that we can, yeah. All right, so now we're going to make a line, and we're going to draw that line in the diagram. We're going to include it, and that's going to be an edge by vertices, I comma target. So we're going to draw an edge between those 2 points. And then we're going to calculate the direction or the vector of that line. So we're going to call that direction, and that is going to use vector by vertices I, and that you should put in a list, sorry, so that's going to be square bracket I comma target. We could have also done edge dot direction, and that gives you also the direction of the edge. It's all the same. Okay, great. We have the direction, we have the I, we have everything. We only need now the field of view. So you can choose any kind of field of view that you want. I'm going to call it F of V, and I'm going to set it to 120. Okay, so now is the time to create the Isovist. So ISO, I'm going to call it ISO, is equal to face.isovist. And what does it need? It needs a face. So face is equal to the boundary, of course, that we created before. It needs a vertex. So the vertex is equal to I, that we just created. it needs a direction, and that's equal to the direction that we just calculated, and it needs a field of view, so field of view is equal to FOV, and a tolerance. I'm going to set a tolerance equal to 0.01. I don't believe it actually matters at this point, but let's just set it to that. And that's it, really. That's the Isovist. This has been created already at this point. We could just simply say at this point topology.show boundary and Isovist and ISO, and let's see what it looks like. So hit Shift Enter, and let's see what it looks like. And there it is. You can see it better actually from underneath because you get a bit of a contrast on it. But that is what you see at that point. So you are starting at the beginning of the vertex is here and it's looking in a certain direction and it's getting the Isovist. Okay, but now let's make it look much nicer than this. So let's set up our Plotly data that will display it much nicer. So I'm going to start with something called data 00, and that is a plotly.data by topology, and I'm going to draw the eye, and I'm going to give it a vertex size of 8, so quite a large circle, and a vertex color of red. So that is the eye. Data 01 is Plotly by data, sorry, not Plotly by data, excuse me, data by topology. Oops, gonna make, and we are going to clump together the eye path, the target path, and the line. So we're gonna make a cluster out of those. So cluster by topologies, the eye path, the target path, and the line that we just created between the eye and the target. And for this one, we're going to use a gray color. So edge color equals gray. And we leave everything else the same. So that's data 01. Let me just make sure because yeah, I made a mistake here, just a syntax mistake. Once you do by topologies, you need to close it right here, and then comma edge color belongs to data by topology, and we don't need this double thing over at the end. I think this is correct. Just let me take a quick look. Yeah, that looks right. Right, so data 02 is now what should we do for data 02? Oh, I think I kind of did not follow the thing, but let me just do data 02 to be the ground. So plotly dot data by topology, and we're going to do the ground. And do we need to do anything else? No, I think ground we can just leave it as it is. And then data 03 is the boundary. So plotly dot data by topology. I know it's a bit tedious this way, but it allows, by using data, it allows you to customize the color, the line weights, the transparency, all of that for per item. So you can set it exactly as you want. But it is definitely yeah, a little bit time consuming. So we're going to do a boundary, and the only thing we're going to do with the boundary is that the edge width, we're going to set it to 4 so that it gets a little bit of a nice outline to it. And then we're going to say if there is an isometric, just in case it fails and it doesn't make an isovist. Whenever I see ISO, I go isometric because of my training, but it's an isovist. So if there is an isovist, data 04 is equal to plotly data by topology, and we are going to translate it a little bit so that it does not sit on the face exactly. So we're going to translate ISO by 0, 0, 0.1, and we are going to give it a face color equals to yellow, and we're going to say we don't want to see the vertices, so show vertices is equals to false. If there isn't, so else, if there is no ISO, then data04 is equal to an empty list. Great. So now we have our data. We are going to create a plotly figure. So figure is equal to plotly figure by data, and then we string them all together. So data 0, 0, we use the plus sign because they are lists, so we can add them together. Data 0, 1 plus data 0, 2 plus data 0, 3 plus data 0, 4. Okay, so that's the figure. Let's actually add one more thing to the figure. Just make sure that the background is white, because that will affect how it will animate later on. So it's good to have it on a white background, not on a transparent background, which is the default. Great. What else do we need? We need now to set the camera. So figure is equal to plotly dot set camera. Figure, you give it the figure. The camera is going to be at 0, 0, 1, so it's on the origin but up in the Z. And then the projection, we're going to use, instead of perspective, we're going to use orthographic projection. So you can shorten that to ortho. You can type anything. You can type orthographic or ORTH. It will recognize your projection. And that the up vector, which is going to be in the positive Y, or up the screen basically where you're looking at, is going to be the positive Y. So 0, 1, 0 gives you an up direction for it. Okay, so now we can plotly show, just to see it, figure. Unfortunately, we have to give the camera again here. I need to fix that code a little bit, and I'm doing a camera of 0, 0, 10, so I might as well have done that here as well. So it's a little bit buggy here where I have to repeat this. And this is ortho, projection is ortho, and up is 0, 1, 0. Okay, and we are ready to see the result. Oh, I made a mistake. Okay, background. Okay, so it's not background, it's background color. So where is that? That is line 18. We look at here, and it should be background color, I believe. Just let me check. Yeah, and there it is. Much nicer now. It looks, much more readable. We have the red dot, we have the paths, we have the yellow Isovist, etc. So if you are happy with it, what you can do now is output it to a PNG file. So instead of plotly.show, we're going to comment that one out. We'll put it maybe at the very end just to see like an end result outside the loop. But inside the loop, what we can do is we can say plotly figure export to PNG, and we give it the figure, we give it a path, so C users Wasim J in this case, downloads, we can call it, let's say, ISO underscore, and then we can do the plus sign. Now comes J, so we can do a string of J, which converts it into a string, and then we can put some preceding zeros by using the zfill command. Look it up if you have not used it before, and then we'll do a zfill of 3. That gives us three digits, and then plus .png. So this will construct a file name that is called iso underscore, let's say 001, and then .png. And because you're going to perhaps repeat this many times, you should overwrite or set the overwrite to be true so that you can overwrite old files. And if you are happy with it, hit Shift Return again, and then check your file system. Here there should be an ISO 001. So if we open that, there is one right here. So since we have that, so now what we can do is we can go back here and change this to, let's say, 20 of those, and run it again, and let's see what we get. So if we go to the files here, of course, as you can see here, I have them from before. It's probably starting to create them down here. So it will start creating different files. Let's just check our work here. Yeah, it's still running. I do apologize. I did make a mistake. I did not increase J. I did not increment J. So it's actually overwriting the same file, unfortunately. So what we have to do is we have to say J plus equals 1, which adds, oops, sorry. Okay. Let me just make sure. J plus equals 1, and let's go ahead and run this one more time. Oh, I did something wrong here. I think I changed something. One second. So apologies, you probably noticed that I messed up just doing the keyboards. I changed this into a markdown, but now it's back. So as I said before, what you really need to do is increment J by 1 in order for the numbers to change here. So I have to put a new line here and say J plus equals 1, which adds 1 to J, and then Shift Return again to run it. And you just set the total number of frames that you want. So in this case, we're going to get 10 frames, and you run it like that. And you should see your files starting to generate in your file system. And now once you're done with that, as I said, you can go to something like easygif.com, which allows you to upload these files. Let's say here, this one's like, I'll just do the ones that I have. Let's say I'll just take a sample of these. Sorry, let's use the shift key here. Upload those. And you get them, and you can then make a GIF. So this is just a sample, of course, of it, as you can see. And then you can crop it if you would like. You know, remove the white space a little bit to make it smaller. Oh, sorry, like this. And then say crop image. And then you can save it. And then you can open the file, and you will see your new animation. And that's it from me. I hope you enjoyed it, and I look forward to giving you another tutorial on this. Thanks.